Okay, I will move on to question 7. So question 7 is about your wave. So for wave, there are actually two graphs. So for question 7, it is showing one graph. Do you know what is the other graph? So for the other graph, it would be this thing called displacement time graph. And basically, they give you the same thing. If let's say on the displacement time graph, you are given this reading, let's say 7. What does this mean? So for wave, there are different parameter like period, like frequency, like amplitude, or like wavelength. So what are these? These are things that we use to define a wave. So what is the meaning of define a wave? For example, if I were to define you, I would say that, oh, you are having a height of 172, your weight is 68, and then your favorite food is so on and so forth, right? I will turn you into a list of numbers. That is what it means by define, right? So I can define a wave by a period. So what is period? Period is basically the time taken. So if you cannot memorize it, I have a way to for you to memorize. You come and approach me. It's not very appropriate, but period basically is time, right? It's time taken, like uh period 1, period 2, period 3, period 4, correct or not? Your timetable is made up of periods, right? So period refer to time, right? And whenever you talk about time, you must ask yourself, this time taken is for what? Is to make or to produce one complete wave. Okay, so that is the meaning of time period. So if you think about this, then what does this graph tells you? You can see that on the x-axis it is time, right? So can you see this is one complete wave, and so this number here tells you the time to make one complete wave. So in another word, this thing tells you the period of the wave. The next thing you need to know is, what is frequency? Basically, frequency is just the number of complete wave you make in 1 second. So if you think about it, I tell you, okay, I make one wave in 7 minutes, right? This 7 minutes will be my period, correct? Period means time taken to make one wave ma. So I make one wave in 7 minutes, correct or not? So if now I ask you, oh, okay, in that case, can you tell me in 1 second how many wave would you make? Well, you say, oh, okay, in that case, I will make 1 divided by 7 times 60 lor, because seconds ma, correct? So what do you see? This is your period. This is the number of wave that you are making, right? Isn't this your frequency? So therefore, actually frequency is just 1 divided by t. Can? So basically from this graph, since you can find the period, by extension of your logic, you can also find frequency by 1 over t. Can? So this is the other type of wave graph. So now you are given this. What is this? This is distance, right? Then you ask yourself, okay, I have this, then I make this. What is this distance? Well, this black line that I have just drawn, right, describe complete wave, correct or not? So the width of a complete wave will give you the lambda, which is the wavelength, right? This is called wavelength, the length of the wave, right? So of course, if you look at this, this is one complete wave, right? Then how about this? This is half a complete wave, right? So therefore, just by looking at this, you will already know that, oh, 1.5 complete wave is 6 cm. So you can actually find out one wavelength is how much. Yeah. Okay, let's look at the questions. Amplitude is from maximum to the neutral. So it is just 3.0. Remember 2SF. Sometimes I can give you harder question. I can draw something like that. Then I draw the wave here. Then I tell you that, oh, okay, here is 8, here is 12. Find the period. Well, the period would be this law. This will be the period. Can? Or if you want, you can say, oh, I will take this divided by half. You can also do that. Okay, wavelength, I think we have talked about it. Wavelength, you can find it this way now. So you can find the wavelength. Okay, I'm not going to do the math for you. Okay, for part C, to find the speed of wave, right, a lot of students will immediately think of V equals to F lambda. Well, in this case, you can do that because you are given the frequency. Okay, so sometimes in your end of year paper, you can see that the distance between the value is pretty big. Okay, so when you are stuck, just refer to the top and see if you can find any help. So in this case, you can actually find the frequency, and you have obtained the wavelength from B, right? So you can actually solve this with ease. And of course, remember 2SF. Okay, I just want to warn you, not every time you must use V equals to F lambda. I hope you still remember this question that says like, oh, I have a water crest over here at A, right? Then after some time, this water crest has traveled to this place called B. Then after that, in the context, they say, oh, okay, I know A and B is about 400 meter. And the time taken for this wave to go from time equals to 0 to time to B is around 60 seconds. Can you find the speed of the wave? So if that is the case, you try to use V equals to F lambda, you will find that you cannot find any data because there's no frequency given, there's no lambda given. So in this case, when you want to find the speed of this particular crest or this particular wave, you can just take distance over time, and the distance is the distance traveled by the crest, which is 400, and of course the time taken in this case would be 60. Okay, so there are different way of finding speed. Yeah, you need to be flexible in this.